VCEs. We have already seen that the hippocampus and amygdala are part of the temporal lobe, and we know that the temporal lobe is extremely important in memory formation. But why is this the case? What is it about the hippocampus and the amygdala that makes them so crucial? This is what we're looking at in this video. Again, we know that these two structures are situated in the temporal lobe of the human brain, and the temporal lobe sits here, behind the frontal lobe, below the parietal lobe, and in front of the occipital lobe. Then, within the temporal lobe, we have the hippocampus and the amygdala. The hippocampus of each hemisphere is very important to the formation of new memories. To demonstrate this, let's consider the case of a man called HM. We now know that HM's real name was Henry Molaison, but we will continue to refer to him as HM. Both of HM's hippocampi were removed. The reason for this was that medical professionals thought in 1953 that it would help to reduce the prevalence of HM's epileptic seizures. When this occurred, HM became incapable of forming new, explicit memories, suggesting that the hippocampus is an important structure in doing so. Explicit memories include things such as semantic memories, facts, figures, and general knowledge, and episodic memories, personal experiences. Interestingly, HM could still form new procedural memories, that is, things such as how to ride a bike, or how to get from one place to another without getting lost. But don't worry, we'll look at all the different types of memory in good time. So the hippocampus, then, seems to be important in encoding new explicit memories. But what about the amygdala? The amygdala works with the hippocampus, but they are not the same, nor do they have the same functions. Whilst the hippocampus tends to work with the facts of memory, the amygdala is more concerned with how we feel. That is, it links human emotions to memories. For example, try thinking about the last psychology class that you had. Your hippocampus is allowing you to remember this event, what happened, where it was held, and so on. But it is your amygdala that allows you to remember how you felt at the time. Perhaps you felt tired, or hungry, or frustrated. So in combination, the hippocampi and the amygdalae are very important. If your amygdalae had been damaged, you might see a redback spider, but not be at all scared. In that situation, the emotion had not been linked to the memory, and that's a bad thing. With that information, we should be able to answer questions like this one from the 2013 VCA exam. It reads, research indicates that the brain area that is involved in enabling intense, emotionally significant experiences to be well remembered is the A, amygdala, B, visual cortex, C, corpus callosum, or D, somatosensory cortex. The answer, of course, is option A, the amygdala. And also this one from the 2012 VCA exam. It asks, despite damage to the temporal lobe, a person should be able to continue to form new A, episodic memories, B, procedural memories, C, semantic memories, or D, episodic and procedural memories. Remember, the hippocampi don't seem to be responsible for how-to memories, such as learning how to ride a bike. These are called procedural memories, so the correct response here is option B. And finally, this case study from the 2012 VCA exam doesn't seem so daunting. The case study seems to be very similar to the case of HM. The individual, Peter, suffers a head injury. He can remember things that happened before the accident, but not after the accident. One of the follow-up questions asks, a scan of Peter's brain after his accident would most likely reveal damage to A, Broca's area, B, Wernicke's area, C, the left temporal lobe, or D, the medial temporal lobes and hippocampi. That sounds a lot like what we know of the hippocampi, so option D is the correct response. Why not have a crack at a few more practice questions on the hippocampi and the amygdalae, available below? Regardless, keep working hard and have a psychedelic day.